Sorry about that. I'm not sure if the video cut out or what, but we had a little bit of a technical difficulty. But we said that 4 times 4 times 6 is the same as our length times width times 6, which we're going to get 16 times 6 when we multiply that out, and that gives us 96 for the surface area of this cube. One thing that I haven't mentioned yet that I really want to mention is that when you have these problems, you're going to be working with some form of measurement. Meters, centimeters, inches, and when you're working with perimeter, you're going to get an answer that is just a number. So 16 just going to be 16, and we'll say if we're working with centimeters, it's centimeters. In area, you'll get an answer that is possibly 16 centimeters as well, but when you do with area, you want to throw squared. So whatever the measurement is, squared will be your answer for area. And with surface area, you want to do this 16 meters in this squared, whatever it may be. So if you're working with any sort of area, make sure you put a square on the end of the measurement, not the end of the number, on the end of the measurement you're working with. So if in this case we were working with centimeters and our answer was 96, we'd say we have 96 centimeters squared. Move on to the rectangular prism. So with the rectangular prism, we have our length, we have our width, and we'll call this our height. When you're labeling these, if you have to label, or when you're looking at one, you have to know which one of these are which. So look at this and determine which three side lengths are of different lengths. So I always try to put our length as our longest, and then the width corresponding to that side. So this length and width both correspond to this base down here. Then the height I would always put as the third value. Really, you can mix these and match these as you choose, as long as they're on the three different lengths. So let's look at our formula. Remember, I said all you have to do here is add up the measurements of the bases. So let's think. We have a length times width, this long figure here on the bottom. Have that. But we got to look. There's also one of that same measurement up here. So we have length times width, and there are two of those. So we'll say 2 times length times width here is going to be giving us the measurement of the area of those two bases we're looking at. So let's look at the other bases. What about this base here? There's one here. There's one here of equal measurement. And that you would get by width times height, because they both correspond to this same base. So we'll go ahead and add that. So 2, because there's two of them, times our height times our width. Plus, there's one more set of sides we didn't look at, and that's this back side here, and this one that is closest to the front. Those share the length and the height as a side. So to get the area of those, we 2, because there's two of them, times the height times the length. Now, one way you can see that you will see this wrote out is all of these are multiplied by 2. So technically, you can pull a 2 out to the front of these. And then, within the parentheses, you'd say length times width plus height width plus height times length. Really, all you're doing here is adding up the area of each surface. It looks complicated with that sort of formula, but it's as easy as that. So let's say our length here is 2, our width is 1, and height is 4. Let's plug it in. We have 2 times our length, which is 2, times our width, which is 1, plus height times width, which is 2, or not 2, 4 times 1, so 4 times 1, plus our height times our length, which is 4 times 2. And then we just multiply these out. So we have 2 on the outside times 2 plus 4 plus 8, which is going to be equal to 2. And 8 plus 2 plus 4 is just going to be 14. So 2 times 14 is equal to 28. So once again, although these formulas look a little complicating, it's important to know that what you're doing, and that is just simply adding up the faces of the shape you're looking at. Now with a pyramid, this one's a little bit different because we're working with triangles and a square. So you want to have to take into consideration the height of each of these triangles in order to add them up. Now in some cases with a pyramid, these triangles will be all of the same measure. Sometimes they won't. So you want to be careful about how you go about answering this. So let me actually all pictured out here and then write out a formula. Call this our height, our length, and our width. So what you're doing here to get the area is or the surface area, SA, surface area. You're taking the area of triangles added together plus the area of the base. And one way to write this out that is a little bit difficult to remember maybe, but this is actually what it would look like if you put that information all together into one formula. You'd have your surface area is equal to length times width plus length times the square root of width divided by 2 squared plus your height squared. We'll move down here. This plus, this is still on the end of this, so this is still continuing on over here. We'll just moving it down. Plus width times the square root of 1/2 squared plus your height squared. Now, like I said, this is huge and possibly a little difficult to remember. But the good thing about this is that if you know how to find the area of whatever the base shape is, in this case it's a square, and you know how to find the area of a triangle, you can simply get the area of each one individually and then add them together. That way you don't have to worry about remembering this gigantic formula. Let's move on to volume. Now, volume is actually straying a little bit different from the other ones. It's more similar to area than it would be perimeter when it comes to the formulas, but it's important to be able to differentiate between the three. So the volume is, I always like to think of how much space is within a 3D figure. That's the question you're really trying to seek there when you get the volume. So the volume is the answer to that question. So how much space? I like to think of it, well, if you were going to fill this up with water, the volume would be the number or the amount that you could fill this shape up with. One thing I will say is the answer to a volume question is going to come out as, let's use the same number we did earlier as an example. If it's 16, we are going to have to say that for some whatever measurement we're using, let's just say 16 meters. Got to cube this one. So volume is 3-dimensional, whereas surface area and area are 2-dimensional and perimeter is 1-dimensional. The actual volume of something is 3-dimensional because if you think about it, you're working in this direction, you're working in this direction, and you're working in this direction. 3 different directions you're actually working in. So you would make sure that this cubed third power is on the end of the measurement used, not on the end of the number, but the end of the measurement used. So with area, one way I like to think about it is you're just taking this base, whatever this base is, in this case it's a square here to make a cube, and it's like getting the surface area of, not the surface area, but the area of this square in every possible position upwards. And that kind of helps me remember how to get this. So without rambling on anymore, let's just down. That's our length. We'll call this our width, and then what we'll call this measurement is our height. So for the square, you want to get the area of the base and multiply it by the height. So the area of the base would be length times width, or in this case, because it's a square, you could say length squared or width squared, because we got to remember those measurements are the same. And then you multiply that by the height. So the volume in this, let's say our length is equal to 2, and we'll say centimeters. then the answer we come up with would be 2 times 2 times our height, we'll say, is 4 centimeters times 4 is going to give us 2 times 2, which is 4, times our 4 we had originally is going to give us 16 centimeters cubed. Because remember, volume is 3-dimensional. We're working in 3 dimensions, so you got to have that cubed out at the end. So length times width times height for a triangle, but that is also the same you would do for a rectangle. So we have our length here, our width here, and our height here. Once again, it is area of the base times our height. Or really, you can get an area of any base and multiply it by the what you didn't use. So example, if I wanted to use this base over here, I could multiply my height and width and multiply it by the length. So any way you want to go about this, I think this is probably the best way to go about it. The example I'm about to write out here, which is the same as the square, length times width times height. So if we had a length of 6, width of 2, a height of 4, we could say, well, this is going to be equal to 6 times 2 times 4, which is just going to be equal to 12 times 4, going to be equal to 48. And remember, let's say this was working in centimeters, we'll say centimeters cubed. We got to remember that cubed with volume. Squared with area, cubed with volume. Now let's move on to the cylinder. The cylinder is where we start to incorporate the use of pi, because if you think about a cylinder, we're using circles. So like I said before, what you're doing is you're getting the area of the base and multiplying it by the height. So in this case, we'll be given the radius and we'll be given our height. And we will say the area of our base, which is a circle, the area of a circle is just pi times radius squared. So we have to get the area of our base and multiply it by our height. So pi times radius squared times height equal to the volume of a cylinder. So if our radius is 2 and our height is 6, we can say pi times 2 squared times 6 is going to be our volume. So that would be the same as pi times 4 times 6, which would be equal to pi times 24. And we can just rewrite this to 24 pi. So with a cylinder, you really just have to remember, well, the volume is the same as the base times the height when it comes to prisms, such as the rectangular prism, the cube, and the cylinder. So all you have to remember is that, well, I have to get the area of the circle, and I'll multiply it by my height. Instead of having to remember pi times radius squared times height as a completely different formula, you can think of it as a combination of two. Just like we did in the cylinder example, we're working with a circle in this cone example. The volume of a cone, we deal with the radius of our circle, just like we did with the cylinder one. But in this one, similar to triangles, we're working with a height value. That's from this point down to the center point of the circular base. That gives us our height. So the formula for this one is 1/3 times pi times radius squared times height. This seems like a lot of steps, but one thing I like to think of is the cone is kind of like a cylinder if you just shaved off a portion of the top of it. So it's a fraction of a cylinder. You just have to remember what fraction it is. It happens to be 1/3 because if you look, this portion of the formula is the same for finding the area, or not the area, but the volume of a cylinder. So it's very similar. I feel like if you know one, you may be able to remember the other as long as you know that it is 1/3 of the cylinder. So let's say that we have a radius of 2 and a height of, 4. Let's plug this in. We have 1/3 times pi times radius squared times height, which is going to be equal to 1/3 times pi times our radius squared, which is 2 squared, times our height, which is 4. And that will give us 1/3 times pi times 4 times 4, which is going to be giving us 1/3 times pi times 4 squared, which is just, we'll write as 16. So then we can pull this 16 pi on top. We are left with 16 pi over 3. And that's how I would leave my answer. But remember, on the state test, you're going to have multiple choice. So if you come to this answer, and this is not one of the answer choices, put that into your calculator and see if the decimal version of this is an answer. One thing you may do as well is say, well, maybe another way to write this answer would be 16 over 3 times pi. That's the same. So if that's an answer choice, that's also correct. And then you could get the decimal, whatever it may be, for 16 over 3. So if you have that decimal value, you could write it out and then have your pi out beside it. So be careful when answering these. One trick, if the answers you have on your paper match up with nothing you see on the state test, one good way of solving or trying to figure out which two are the same is to simply put the answers from the state test in the calculator and put your answer in the calculator and see which ones match up as far as decimal form goes. So let's move on to the sphere. The sphere is an interesting one because the formula is just a bit odd in my opinion, but it shouldn't be too hard to remember. So when we're working with the sphere, we're working with a circle, just like with the last two. Circle in the middle that kind of makes up the sphere. So that means, just as you guessed, we are going to be working with the radius of that circle. And our formula for the volume of a sphere is 4/3 times pi times radius cubed. It's interesting, nonetheless, but it's not that bad to plug in and use, as long as you can remember it. This one, I don't have any quick tricks or memorization tips for you, but this is one I would just suggest you look at and try to remember the best you can. So in this case, we'll say, let's let our radius equal 6. We'll use 6 as an example. We have 4/3 times pi times 6 cubed. And that would get us 4/3 times pi times 216. And if you don't know these off the top of your head, that's fine. Put them in the calculator. Utilize your calculator on the state test. Don't guess because you're trying to get through it quick, and don't use the calculator. So what this gives us is, well, we can pull this 216 on top. So we multiply it by that 4. And that gives us 864 divided by 3 times pi, because we want to leave our pi out front. And then that gets us to 288 pi. Basically, this right here just simplifies down to 288 over 1, which leaves us with just 288 pi. But remember, on the state test, I'm going to repeat this, it could give you the decimal version of the answer, so be careful when choosing answer. Lastly, we have the pyramid here. Going to utilize this height value right here, and the length and the width. The formula that we use for this is 1/3 times length times width times height. So we basically, length times width is going to be equal to our base, this square looking base down here. That's the area of that base. And then our height, we multiply it by our height to move that square up, whatever this distance is. But remember, if you think about it, if this is a perfectly square base, then this pyramid is just a fraction of a cube. There's some space you could fill in on top to make this a cube. So if you'll notice, the length times width times height, that is our formula for finding the volume for a cube or rectangular prism. And this is just a fraction of that, so that's where we get that 1/3. So in this case, let's say our height is equal to 6. We'll say a length is equal to 4, and our width is equal to 3. So we have 1/3 times 4 times 3 times 6, which gives us 1/3 times 12 times 6, which gives us 1/3 times 72, which is equal to, we pull that on top, 72 over 3, which would just equal 24. So with this one I would pair up and think about it alongside that equation for the volume of a rectangular prism or a cube, because it's very similar, and knowing one may lead you to remembering the other. Lastly, let's move on to abstract shapes. You will definitely run into these on the state test, and it's important to be able to know how to work with them. So we're going to focus here on first perimeter. We want to get the perimeter of this abstract shape. So we got to think about what we know. There's no formula out there just to give us the perimeter of this odd shape. So what you want to do, break this up into things we do know. So if I were to draw a line right here across this, I have broken that up into two rectangles. And we know how to find the perimeter of a rectangle. The only issue we are running into now is that we need to know what this side length is. So if we wanted to find that side length, we would say, well, I know that this whole side over here is going to be equal to 9 centimeters. I also know that this right here is a portion of that side, this portion to be specific, and it's 2 centimeters. So this side right here is equal to 9 minus 2 centimeters, which is going to give us 7 centimeters. So we broke this up into two pieces of things we know, and we have 7 centimeters here. And now we can just add up what we have, the outside, the way around. Actually, I'm wrong, because there is one little space up here that we don't have either. But we do know that this portion is equal to whatever this measure is down here. So if we break this up and say, well, this is 6 centimeters, so this must be 6 centimeters. But this whole side is 10, so if this is 6, then 6 minus, or 10 minus the 6 will give us 4, and that'll be here. And we know that's the same as up here. So up here we have 4 centimeters as well. So now it's as simple as adding up the side lengths. So we have 4 plus 7 plus 6. So I'm just going around this way and adding these together. Plus 2 plus 10 plus 9. And it's important to know here we're just adding up the way around when we're working with perimeter. You don't want to, although we know this little dotted line on the inside is equal to 4 centimeters, we don't want to include that because we're just worrying about the way around the outside. So we can do what I like to do when adding up long strings like this, so just pair it up. So 4 plus 7 is 11, plus 6 plus 2 is 8, plus 10 plus 9 is 19. Then we can just add up. Well, 19 plus 8 there is going to be, this is going to be equal to 19 plus 8, which is just equal to 17, plus that 11 we have left over. We can add those together and we get 28 as our perimeter. Remember, that is in centimeters. So we do a very similar thing to this when working with area. So say we want the area of this. We've already done the majority of our work that we need to do to find the area. To find the area of this, once again, there's no formula that just says, okay, this is what you do to find the area of this abstract shape. So what we have to do is break it into pieces we know. We do know that this bottom portion down here is a rectangle, and this side portion over here up is also a rectangle. So if we get the areas of both of those and add them together, we should have an answer. So our length of this bottom one is 10, and our width would be 2. So we have 10 times 2, but we want to add that to the area of the other. And up here we have 4 and 7 as our length and width. So we'll say 4 times 7. And it's as simple as multiplying together and adding them. So 10 times 2 is 20, plus 4 times 7, 28, giving us an area of 48 for this entire shape. Do another example. The first thing you should think when you look at these is what do I know that is there? What do I know that I can solve for? So let's break this off. This breaks it into a rectangle and a triangle, so I can solve for those things. Let's see. This side on the inside here is pretty important for us to know at some point, and you'll see why as we go, but it's always important to mark those unknowns as you go as well. So we know that this side length right here is equal to the difference in this side length and this one. That's what's left over. So 18 minus 11 is going to give us 7, and that's the length for this little inner side here. Now we have some more information that helps us. So let's go ahead and try to get our perimeter. We have perimeter is equal to, well, we have this 14 plus 18 plus 20 plus, well, we don't have this side length right here. This side length we do need. Let's think about how we can get that side length. Well, we do know that this is a right drawn off. So maybe we can try using the Pythagorean theorem. So we have one of the sides, we just need the other leg. Other leg is right up on that side. So how would we get that? Well, we know that this portion of the line is just the difference between this bottom one here and this long one across the top. So in order to get this line that I highlighted in our racing, want to find the difference between 20 and 14. 20 minus 14 gives us 6. So now we have 2 out of the 3 sides of that triangle, both of which being legs. Hypotenuse is all that's left. So we know that 6 squared plus 7 squared is going to equal our c squared, so our hypotenuse squared. That's using the Pythagorean theorem. Then we are left with 36 plus 49 is equal to c squared. So then we just add those together and get the square root. So in this case, we have 36 plus 49. That's going to give us 85 is equal to c squared. We take the square root of both sides. We're left with c is equal to square root of 85. So now we use that information to say, well, that this side length over here is the square root of 85. Here to get this erased. Okay, so we can add that on, square root of 85, and then our last side length here is that 11. So then you can add those together, and you're going to get something like, well, 14 plus 18 plus 20 plus 11. So 14 plus 18 plus 20 plus 11 is going to give us 63, and we're left with that square root of 85. So you may have an answer, something like this. Remember, be careful. The state test will give you answers that may not be exactly what you have wrote down, but are still correct. But if you were to write this as a decimal, it'd be the same as 16 or 63 plus something along the lines of 9,219,5, and it goes on after that. But we add that to our 3, and you would get 72.2195, and so on. So let's think about area. Now we've added up all of the outside of this shape. Let's think about the area of this shape. So we have a rectangle with a length of 18, a width of 14. So our area of this portion is going to be, well, 18 times 14, and that'll give us this portion, all but the triangle. But we can't forget that triangle. 7 back. So we have the 7 there. Now we need to get the area of the triangle so that we can finish this off. And if you remember, the area of the triangle you get by multiplying the base times the height. Well, we got to think about this triangle. This is a right triangle. What would the base be? Well, the base of a right triangle is just going to be equal to one of the legs, while the height of the triangle is equal to the other leg. So in this case, we know that our base is either 6 or 7, and if our base is 6, then our height is 7. But we're not quite done, because remember, we have to multiply that by 1/2 or divide by 2, either way, to get the full formula there for the area of a triangle. The area of a triangle is base times height divided by 2, or 1/2 times base times height. We figured out our lengths here, and we've put them all together. We just now have to multiply this out and get a number. So 18 times 14 is going to be equal to 252. Then we have over here or 6 times 7 times 1/2, or we could say divided by 2. 6 times 7 is equal to 42, and divide that by 2, and you'll get 21. And this will give us answer 273. And if we're working with whatever we're working with, in this case we're working with meters, you got to remember to write meters squared. Remember, area is two-dimensional. Area is squared. That's a lot of work, I know, but if you know everything we went over in the first few slides of this, this should come pretty easy because you'll know how to break this apart into things that you can understand. I'm actually going to skip this example because this is one example that you will do on your worksheet. So we'll not worry about that. Let's get into working with these sort of figures for surface area. So for surface area, we said you just add the area of each surface, and we had different formulas for each of those. But in this case, we have some sort of odd shape that we may not necessarily have a formula for. So let's look. We have shape here, and I'm not going to outline all these shapes, but there are multiple different shapes that we are working with, and you can use the information to fill out of certain sides that is given to fill out the rest of the information for others. So really what you want to do is, what I would do is label these. So this is 1, 2, 3, 4 in the back there, 5 and 6. Don't forget the matching ones like 7 out here in front. Maybe that's not the best way. You can maybe not write them down, but you just remember which ones you're going for. So let's say this here is first. We want to get the surface area of this. Well, that's just a square, or a rectangle, I should say. That's just a rectangle. So we would do 6 times 5. That's going to give us 30. So we have 30 here as the area for this portion. So this portion is done. We'll outline them as we finish them. So let's work on this top one here. That is 16 as the length and 6 as the width. Then we can just say, well, the area of that surface is 16 times 6, which would give us 96. So now we have this surface taken care of. Now let's work on this bottom one, long one here at the bottom. This is just has a length of 24 times our width of 6. 24 times 6 is give us 144. It is done. Then let's work on the back one. So this one has a excuse me. This one has a length of 16, but wait. Where's the height? Not labeled here, or the width. The length of 16, where's the width? It's not labeled here or here, but we know that because of the way the shape is laid out, that this 6 over here transfers to over here. So this is the same as 16 times 6, which if you look just above, we've done 96. So this shape. We only have a couple spaces left here. What about this one? This space here. This space, well, we know that this 6th also transfers up here to this side, which means it also transfers to this side. That's equal to 6. And this portion here is just the difference in this long side and this shorter side. So 16 minus that 5 gives us 11. So we have 11 left here. So 11 times 6 gives us 66. And we are almost done with getting the areas for all these individual surfaces. Then we have this top portion here. And let's think. Well, this 6, if it's here, it also transfers to up here. So that's the same as 6. And then we have this long side of 24. And we know that this side is 16. So in order to get this portion up here, we want to do the 24 minus, which would give us 8. So now we have 8 times 6. That would give us 48. They may think, well, that's a lot of work, and it most definitely is a lot of work, but we're not quite done. We have one more step left, and that would be to add all of these together so that we get some kind of final conclusion of our total surface area of this object. So we would have 30 plus 96 plus 144 plus 96 plus 66 plus 48. And if you put that in your calculator, you end up with a total of 480 centimeters squared as your surface area for this shape. So that's a lot of work, and I know this video is very long, so I appreciate you looking this far into it and working with me here. That is a lot of math there, but remember, there's a few trick little things you can do. The perimeter is as simple as adding up the outside parts. You add up the outside parts. That gives you the perimeter in any way or shape you're looking at. With the area, you really want to multiply your length and width when it comes to rectangular or squares. But triangles, circles, and other shapes have different formulas that you have to remember. So be careful with those. With volume, it varies from shape to shape. So these are formulas you also want to remember. One thing I want to touch on before we finish up here is that you will have a formula sheet that you'll be able to use on the exam. The formula sheet has several of these formulas. For example, it has the area of a triangle, a parallelogram, and a circle, and it has the volume of what your general prisms, like rectangular prisms, squares. It has cylinders, spheres, cones, and pyramids. So a lot of these you may not have to commit to memory exactly. You just have to be familiar with how to use them. I appreciate you guys for watching this far into the video. I know it's long, so I'm not going to drag it on anymore. Make sure you get that worksheet finished, and if you have any questions, feel free to ask me or Mr. Rose.